Determine the BCD equivalent of the following excess-3 code. So in this question, we have been given a code which is in excess-3, and we are supposed to determine the equivalent BCD code. So when you are given an excess-3 code, to get the BCD, remember BCD and also the excess-3, both of them, they are normally packed into 4 bits. So from each group, you subtract 3. So it means the number is already in excess of 3, and the excess of 3 normally applies for every group. For example, if it is in decimal and we have 2, 3 base 10 and we have to convert to excess-3, we normally add to each digit, we add 3 to get 6, 5. And from there, now we convert this to the specific binary digits using 4 bits, such that now this one will be 1, 0, that is 0, 1, 0, 1. This will be 0, 1, 1, 0 in excess-3. So now this number is already in excess-3. That is the number. So to get the original, we subtract each group 3. And 3 in binary and in 4 bits is 0, 0, 1, 1. So we subtract this to every group. So this group we subtract 0, 0, 1, 1. We do the same here. We do the same in this one. And lastly, we do the same in the last one. So after we subtract, the answer will the answer will be now the BCD code. So let's subtract for every group. So every group is independent, so it is not depending on the other group. So we have 1 minus 1 is 0. Then 0 minus 1, we borrow 1 here, we remain with the 0. We bring it here, we have 1, 0, which is 2. We subtract 1, we get 1. 0, 0, we get 0. And 1, 0, we get 1. Then here we borrow from here to get 1, 0, which gives us 1. Then the next one is a 0 minus 1. So we borrow from the far left, we remain with the 0. We bring here in at the middle column where we have 1, 0. We borrow again, we remain with 1. We take it here to have 1, 0, which gives us 1. Then we have 1 and 0, we have 1. And lastly, we have 0 and 0, we get 0. 1 minus 1 is 0. 0 minus 1, it is impossible, so we borrow from here, we remain with 0. We bring it here, we have 1, 0. We borrow again to remain with 1. And we bring it here, we have 1, 0, which is equivalent to 2. We subtract 1, we get 1. We get 1, and we get 0. And lastly, we have and 0 minus 1, we borrow from here, we remain with 0. We bring it here, we have 1, 0. We borrow again, we have 1. We bring it here, we have 1, 0, which gives us 1. Then 1 minus 1 is 0. 0 and 0 is 0, and 1, 0 is 1. So we perform normal binary subtraction at each group, subtracting the equivalent binary value of 3. So the final answer of this question will be 1, 0, 0, 1. 0110 0111 1010, and this is in BCD code. So that is the answer. Here we have 1, not 11. This is 1001. So the others are right. So that is the answer.